Morning, welcome back. All right, so I think I'm all set up. I don't know, we'll see. We had our test, that's right. Okay, so it's all slowly gonna come back to me, I guess. Oh, I mean, the line's on here, otherwise it'll be a mess. Change this. Give you guys some time to get organized. Math 120. February 23rd already. Crazy. All right. So, test one was really good. So I did send out an announcement. So I did adjust your grades in case I felt like you should have more marks than what you had on your web assign test. And so I did adjust those based off of your work, which was really good for a lot of people. So I'm obviously going to keep doing that because I want to check your work. There were a couple of times where I had to remind myself that I wasn't taking marks off this time. So because out of nowhere, the right answer would appear, and I don't like that. So in the future, for future tests, I'll be potentially taking marks off if your work doesn't support your answer. So, but I will say really, really good job on test one. I was really pleased overall. And I made some comments on your written work. I'm not sure how to access that, but if you want help accessing the feedback, then let me know. But hopefully it's easy on your end. So I will say, oh, I don't like this thin pencil. It makes me write too hard. Great work on test number one. For test number two and the final exam, I will reduce your marks, just as a heads up, if your work does not support your final answer. If your work does not support your final answer. Okay. Another thing that I kind of landed on during the reading break was because I haven't had this whole term, I've had 4 hours of office hours every week, and I think I've had a total of 3 people this whole term show up. So instead, and then I have, by appointments throughout the week. So what I've decided to do is office hours will just be by appointment. I'll put my schedule up so you know when I'm teaching other courses. And then just kind of anytime that seems, reasonable, kind of anytime before 5, I'm usually available. And even after that, I'm often available. So I will make a note of that here, but I'll also post it in the top on our Moodle page. So not to worry. So office hours will now be by appointment. Anytime, any day, really, because I'm usually available. I am usually available on short notice. So I'm going to make that change just because it's, I do get some work done, but sometimes it's just nice to, I don't know, not be staring at a blank screen forever. Good. Okay, so we've just got this last section in chapter 1, and we did have the test, and there are some things from chapter 1. Of course, chapter 1 is called the fundamentals, so of course we're going to revisit everything, and it's going to come back up. But I'm not going to spend any time reviewing it because we'll come back to it as needed. Okay, so but I do want to talk about lines. It's a short section, but it's going to be really important. It's an important section just for whether you take, if you go into business math, I don't know what program you're in, if you take calculus, having a good handle on lines, straight lines. I know that sounds really stupid, but having a good handle on straight lines and all their properties is going to be really important. So kind of regardless of what area in math your next step is, even if you go into stats, remember stats is my jam. So definitely if you're doing statistics, then you'll need straight lines. So kind of regardless of what your next math step is, you're going to need lines. So the concepts are not bad, but we do need to do a little bit of work in here, but it is kind of a blink and you miss it section, but I want to emphasize it is really important. So 110 is called lines. So we've got straight lines. You might remember y equals mx plus b, right? And so we're going to talk about that, just kind of properties of straight lines, what makes a straight line. And we've got our little handout from 110. Okay. So we'll kind of start at the beginning, and the slope of a line, right? So you can have a line and we can talk about the slope. The slope of a line in its most basic form is just the rise over run, right? And so the slope of a line well, it's hard to describe the slope without using the word, but it describes the incline, right? So a large slope means that you have this kind of steep incline, and then a small value of the slope is going to be kind of this shallow incline. And so steepness isn't a word, but they even had to use it in the textbook because there's not really like a proper word. So the slope of a line tells us the steepness, okay, of the incline of the line. Tells us the steepness, and I'll put that in quote because, well, it's not really a word, but I was kind of justified last term. I was searching for the word, and then when I finally looked down at the notes and realized that the textbook had also had to use steepness, I felt a little bit better about it. So the slope of a line tells us the steepness of the line. Okay. So a small value of the slope might look something like this. So I'm going to do my XY plane here. So I've got my X and my Y. And this is kind of our default grid here. So here we'd have a small slope, right? Or a large value of the slope. would look something like, and I'll try to keep it on the same page here. Sketch out my XY grid, and I'll use a different color. And so something that looks like this. All right, so notice just the incline. Okay. We can also have positive and negative slopes. So positive slopes are ones that are going up, 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 right? So as X is increasing, Y is increasing. I always find that's a little bit difficult to think about. But if you're thinking about, okay, if you're looking at this graph and it's going up into the top right-hand corner, then you have a positive slope, right? So here, these are positive slopes. Whereas if you have, let's draw another one here. If you have a slope, now I'm going to do a small value for the slope here, but if it's kind of like, oh, that's a little bit steep here, there. Okay. Oops. This would be a negative slope. Okay, so that's a small negative slope. And then a large negative slope, let's draw that as well. Got to catch them all. Oops, yes, I should. X, Y. Okay, now I'm doing a steep slope here, steep negative slope like that. So it's going down into the bottom right. So this is also negative. Positive. All right, so just these properties tell us a lot about the line, okay? Whether it's positive or negative tells us the direction, right? And then the actual value of the slope tells us how steep we are. So the slope of a line, oops, it's not one word, there, two words, is usually denoted by M, denoted by a lowercase m. I don't know why that is. I can't think of a reason why off the top of my head. Maybe all the other letters were used. But anyways, we use M, a lowercase m. Now, you might remember that the slope is rise over run, right? So at its very core, the slope is rise over run, which if we look at just a basic positive slope here, when I draw a general line, I'll usually draw something like this. I default to positive slopes. They can be negative, it doesn't matter. But the rise, right, is the difference in the y, and the run is the difference in the x. So it doesn't matter what 2 points you pick on the line, but we need 2 points on the line to figure out the rise and the run. So we can pick this value here, right? And we can pick this value here. Doesn't matter. I'm picking those arbitrarily. Okay. Now, you might remember we haven't talked about it too much, right? But in a grid like this, we usually have these ordered pairs, and so this, let's call this the first point here. I'm going to call this x1, y1. Okay. And then here, I'm going to call this x2, y2. So I'm using little subscripts x1, y1 to indicate that, okay, well, here this is at x1, y1, and this is at x2 and its corresponding y2. Okay. So with any 2 points, we can find the slope of a line. Okay. So with any 2 points, x1, y1, and x2, y2, on the line, we can find the slope. So on the line, we can find the slope. Okay. Now, remembering that the slope is rise over run, right? So the rise here is the distance, is the distance between y1 and y2. Now, to kind of to keep that positive and negative, what we have to do is we have to do y2 minus y1 to get that distance, right? Because y2 is going to be larger than y1 if it's positive, right? And so, and then same thing for the distance between x1 and x2, right? x2 is larger than x1, and so it doesn't really matter, but just for consistency, we're going to use y2 minus y1 over x2 minus x1, and I think it's on our handout, so why not just grab it there. Okay. So here, let's bring that in. Kind of drew those other slopes already. Okay. So here, right, this is what we just established, right? That the rise here, if we refer back to, I'll try to keep it on the same page here. If we refer back to our little graphic, right, the rise would be y2 minus y1, right? And so that's what we have here, y2 minus y1. And then the run is the distance here. And you even had it on your test, right? How do you find the distances between 2 points? We use the absolute value, but now we're gonna drop the absolute value, but the distance idea still stays the same. We take the last point, or the rightmost point, minus the leftmost point. Or if you just want to remember this, that's fine. So here, right, the rise over run, the slope becomes y2 minus y1 over x2 minus x1. Okay. So to find the slope, we just need to have 2 points on the line. Kind of in the other direction, if you have to draw a line, so if you have to draw a straight line, right, all you need are 2 points on that line, and then you can connect those dots and extend the line, right? And so you only ever need 2 points on a straight line. And I use that all the time, right? If I'm, I really like to do kind of woodworking. I'm not very good at it, but you know, I want to cut pieces straight and that kind of thing. And so you only need 2 points, right? And then if you can line those up with a straight edge, then you've got a straight line, right? And so so that property really comes in handy in, I don't know, in real life, I guess. But for us, kind of going the other way to find the slope, we only need to have 2 points on the line, and then we can find it. So let's do a couple of examples. I got a markup on this one, so it bumps it to the top here. Yeah. So usually we'll label our points, right? So here we might call this first point P and the second point Q. It doesn't matter which one's which, but that's usually how we label them. So here, find the slope of a line through P and Q, right? So here we've just got these 2 points, and we have the point name out front, right? So P is at the point X is -1 and Y is +2, and then Q 0, 0. So 0, 0 is the origin. Now, we haven't talked too much about kind of geometry and trigonometry, but we'll get there. Okay, so you should probably be able to plot these out. We don't need to, right? But let's do 14. Right, we'll just do one of these, but I want to pick one. They're all the same, but so here, if I have my XY plane, okay, P is at when X is +4 and Y is +3, right? So just remembering that X comma Y is how we read these. And so I know I have to have 1, 2, 3, 4, and I'm just doing points arbitrarily. It's not going to be a very nice graph, but we're just sketching it out. And we don't need to sketch it out. It's just to get an idea of what's going on here. And when Y is 3, 1, 2, 3, let's say. Okay, so here, let's call this P is at 4, 3. So here's 4 and here's 3. Q is at 1, -1. So here we've got 1, and then we have to go down 1 on the y-axis. So here, 1, -1 might be here. Q is 1, -1. Okay. So notice, right, if I have these 2 points, and I didn't do a very good grid here, but it's okay, we'll survive, right? So now what you would do is just, I'm trying to find a straight edge, and any straight edge will do, right? Sometimes I'll fold over a piece of paper and just kind of use that. But what you're gonna do is you're just gonna connect these dots with a straight edge, and the line keeps going. So a property of a line is that it just keeps going to positive and negative infinity. So it'll just extend. Obviously, we're only looking at a small portion of it. But so now I'm placing my pen, my straight edge, any straight edge, on top of my screen, which doesn't really work, but I'll make it work here. Oh, sort of. Doesn't like it. I'll just cheat and use the, doesn't look very good, does it? Oops, now I've done it. There. Okay, so I'll just make a note here. We don't need to draw it out, right? We can just use the formula to find the slope. Okay, so we do not need to draw the line to find the slope. Okay. I just wanted to expose us to drawing a line, and so that's why we did it here. But what we know, the slope, right, is going to be y2 minus y1 over x2 minus x1. Now, as long as I use the subscript 1s from one point and the subscript 2s from another point, or maybe vice versa, it doesn't matter which one, okay? And so you have to pick kind of which one you're going to use as x1. So here you've got y2 minus y1 over x2 minus x1. For kind of simplicity's sake, okay, I'm going to use this q as my subscript 1 and p as my subscript 2, just because it just reads nicer. Doesn't matter. Okay, so this becomes y2 is 3 minus y1, which is negative 1. Make sure you keep that negative on there, over x2, which is 4, minus x1, which is 1. Okay. I'll make a note above here. It doesn't matter which point is x1, y1 and x2, y2, as long as you're consistent. As long as you are consistent. Oops. Okay, so that's kind of nice. So now, right, speed this up a little bit, only because I've got a little page break here, so I don't want to mess around. So I've got 3 minus negative 1, that's the same as 3 plus 1, so that's 4 over 4 minus 1, so it puts me at 4 over 3. So the slope here is 4 over 3. And I would just leave it as that, right? All we're asked to do is find the slope. Okay. Let's do 16. Yeah, maybe it's good to see 16. 16, I'll copy it down here. The first point is 3, negative 2, and Q is at 6, negative 2. Okay. So I'm not going to draw these out, although if you did, you might see what this means more clearly, right? If they have the same y value, okay? But let's see what happens here if we just go ahead and calculate it. So we've got y2 minus y1. So finding the slope, y2 minus y1 over x2 minus x1. Okay. I'm just going to read these out. So this I'll use as subscript 1 this time, and q I'll use as subscript 2 this time. Right? Doesn't matter. So here, y2 is negative 2 minus y1, which is negative 2. And then x2 is 6 minus x1, which is 3. So the slope, negative 2 plus 2 puts me at 0, right? And then over, well, 0 over anything, as long as we're not dividing by 0, right, is just going to be 0. So 0 over 3 means we have a slope of 0. Okay. What does that mean? A slope of 0 means that we have something like this, just a straight horizontal line, okay? Because regardless of which value of x I put in here, my y value stays the same, right? So if you have a slope of 0, and remember the incline, what we said first, right, was that the incline, the steepness, is the value of the slope. So if there's no steepness, well, it makes sense that the slope would be 0. Okay. What if we have to, consider consider a line that looks like this, right? So now, what if I have a line here? Straight vertical line. Well, remembering that the slope is rise over run, if there's no run, right, then, so here, this would make no run, so we're dividing by 0. We can't divide by 0, that's illegal math. So what we say is this slope is undefined. So here I'm going to say it's rise over run, but run equals 0, okay? Since we can't divide by 0, the slope is undefined. Since we can't divide by 0, the slope is undefined. Right, or it does not exist. Yeah. So a straight horizontal, or sorry, a straight vertical line, there is no slope, right? Sometimes we say no slope, or it's undefined, or a slope of 0 would be a straight horizontal line. So you want to keep track of those. Okay, so we've talked about the slope of a line. That's going to be really, really important. How do we identify a line, a linear equation? So a line, usually we, for some reason in high school, we learned y equals mx plus b, right? So the typical form of the equation of a line, is y equals mx plus b, okay? Where y, of course, is y and x is x, but m is the slope, which we just learned, right? And m is either positive or negative depending on the direction of the line, right? And so the slope determines the direction, and the slope is always attached to the x, okay? So the slope is attached to the x. B, lowercase b, is the y-intercept, right? So that's where the line crosses the y-axis. Where the line crosses the y-axis. Okay. Now the thing is, you need to be able to recognize when you can rearrange something into this form, right? So even if you have something like 4x plus 3y equals 14, right? This you can rearrange, right? You can move things around and solve for the y, and then you'll have something times x and then plus something or minus something for the y-intercept, right? So we can rearrange this and put it in the format of y equals mx plus b, right? So with rearranging, this would be a line. Now to recognize a line, you can have the highest possible power of x and y is 1. Now, you could have no y, right? Or you could have no x. That's allowed, and we'll look at some of those scenarios maybe later. Or you can just play around in Desmos and see what happens, right? But so we can rearrange this into y equals mx plus b. So if the highest power of x and y is 1, we can rearrange into the form of y equals mx plus b. We can rearrange into the form y equals mx plus b. So remember how I said we've worked a lot with quadratics, right? And so I said, okay, it's really good if you can recognize a quadratic, because then you know how to factor it. You can use the quadratic formula. It works every time, right? And so just being able to recognize that form of the equation is really important. So now we're adding another one, a simpler one to the roster. We're saying, okay, well, if you've got one x and one y, or even if you're able to collect like terms, but the highest power of both x and y is just 1, then you can rearrange things into y equals mx plus b. So let's just have a look at this guy here. It's not going to be nice and clean, but it's going to be okay. So we've got 4x plus 3y equals 14. I want to solve for y, right? So I've got 4x I have to subtract from both sides. So I've got 3y is 14 minus 4x. Solving for y now, I have to divide by 3. So y is 14 minus 4x divided by 3. Okay. I can split this up, right? If I want to have it in the form of y equals mx plus b, right, then I can have, this is going to be y equals 14 over 3 minus 4 over 3 times x. Okay. Now, whatever is attached to the x, remember, including the positive or negative, is going to be my slope, right? And then whatever is on its own is my y-intercept. So here, m is negative 4 over 3. Now, it's just kind of fluky or maybe subconscious that I'm pretty sure that's the same slope that we just calculated. Well, but negative, doesn't matter. Complete coincidence. Okay, so the slope is negative 4 over 3, and the y-intercept b is 14 over 3. Now, those might simplify. I don't really care. It's just to illustrate the point. So even if it's not, you know, in mx plus b form, right here we've technically got b plus mx. Doesn't matter. You can rearrange things. Okay, so being able to recognize, oh, okay, this is going to be a straight line because I have one x and one y, I can rearrange it into y equals mx plus b quite easily. Okay, so that's going to be really important. All right, how do we make some lines? There are a couple of ways that we can make lines. If you have the slope and the intercept, well, you're gravy, right? The slope-intercept form is y equals mx plus b. So there are a few ways that we can create lines. Okay. So there are a few, oh, that says a few. A few ways. I'm not committing to the number of ways because there are more beyond what I'm going to tell you, but if you have these core concepts under control, then you can figure out how to make these lines. So there are a few ways to construct equations of lines, or the equation of a line, I'll say. The equation of a line. Okay. So it depends on the information that you have. Okay, so maybe I'll put that in brackets after. depending on what information you have. Sometimes when I say what information you have, you might have to go a little bit beyond, think outside the bun here, and what information can you get, right? So what information can you kind of tease out, right? And we'll see a couple of examples. So the first kind of most common way that we can make a line is the slope-intercept form. So if you have, so the first way is if you have the slope and the y-intercept. Okay, so given the slope and the y-intercept. And I'll grab that little tidbit here. Okay. If you have the slope, remember the slope is m and the y-intercept is b. Well, if you have those two things, then you can just make your line y equals mx plus b. You can just stick them together and be done with it. Okay, that's kind of boring. That's not usually going to happen, right? And so, another thing that kind of gets people is the y and the x, we just let them be whatever they want, right? So they're going to stay variables this whole time, unless I say what is the value of y when x is 4, right? Then you plug in x equals 4 and solve for y. We're not going to do that yet. So for now, x and y are just always held as variables, and they're allowed to just be whatever they want, right? So x and y just stay x and y. More reasonably is if you have the slope and any other point, so not necessarily the y-intercept, but any point on the line. So the other option is given the slope and any point on the line. Okay. So the slope again, of course, is m. And then any point, we'll use, what notation do we use? x1, y1. Sometimes we'll use x0, y0, it doesn't matter. Okay, so now I'm saying, okay, I know the slope and I know a point on the line, okay? So x1, y1 is just a placeholder for the point on the line. Now this, the point slope form of a line, just the name tells you what information you need, right? The point slope, so you have a point and the slope, versus the slope intercept, you have the slope and the intercept. Okay, so the point slope form of a line, you're going to do y minus y1. Y1 is the y value of the point that you know, okay, is equal to the slope that you are given, right, times x, which is just held as x, minus x1, which is the x value of the point that you know, okay. This point slope form of the line is the one that I want you to kind of remember, right? So this one is kind of the really important version. Okay, we can even use this version to arrive back here. Okay. We can use the point slope form of a line to derive, and I'll say derive because this is kind of the first time that we use a formula to derive another formula, okay? So we can use the point-slope form of a line to derive the slope-intercept form. To derive the slope-intercept form. Right. And this is just to show you how they're linked, right? They're the same, but this, if you're going to memorize one, this is the one to memorize, right? And we use this a ton in calculus as well. So if that's where you're headed, then you'll definitely need to remember this one. And I've been talking about it for weeks in that course already. So this is a good one to kind of have up your sleeve, okay? All right, so remember, right, we just need to know a point on the line, right? For the slope-intercept form, we're just saying that, hey, that point that we know is the y-intercept, okay? So if we let x1, y1 be the y-intercept, denoted by, so the y-intercept is when x is 0 and y is b, we call b the y-intercept. Okay, so then the point that we know is 0b. Okay, so what we have is we have y minus y1 equals m times x minus x1. So now, if I have some slope, so any slope, I'm just going to keep it as m, then if I replace y1 with b and x1 with 0, right? So here I'll do a little, oops. There. Then I can rearrange this so I can write those in. So y minus b is m times x minus 0. Okay. If I'm solving for y here, right, then I get y equals m times x minus 0 is just mx, and then I have to add b to both sides, so I get mx plus b, right? So the slope, the point slope form of a line is the more versatile of the two because you just need to know any point on the line and then you'll be able to find the equation of the line. Okay, so let's do a couple of examples here. So here we have kind of varying information, right? And so depending on the information that we have, that's going to determine how we're going to find the equation of this line. Right, so here we have the slope and the y-intercept. So then I can use the slope-intercept form, right? Or if you prefer, right, you can just say, well, the y-intercept is when x is 0. So this is at 0, -2, and this is at 0, 4. But for practice, it might be good to just use the slope-intercept. Now, here, I just have a point and the slope of 5. You could, I mean, in theory, you could plot this point and then have a rise of 5 and a run of 1 and just kind of figure out what the 2 points are. That seems really tedious, so I wouldn't do that. You can, but I wouldn't waste the time because you have the point slope form, right? So here you have the slope and you have a point, so you can use the point slope form, right? Same thing, 25, 26, 27, and 28. They all do the same thing, okay? So we'll do one of those 4, 5, 1, 2, 3, 4. But I also want to do 29, right? So remember how I said, okay, you might be given this information or you have the information to find all that, right? And so here we've just got 2 points. So what are we supposed to do here? Well, if you think back to where we started today, we said, okay, well, if I have 2 points on the line, I can find the slope. And if I have the slope and a point, here I happen to have 2 points, so I have to pick one, doesn't matter which one. And then I can use the point slope form of a line, right? So let's go ahead and I want to do, let's do 26. Okay. So 26, I'm going through -2, 4 with a slope of -1. Okay, so here I'm given a point which is at -2, 4, and the slope m is -1. Okay. So, well, if I have a point and I have the slope, then I'm going to use the point slope form of a line. So I always write down the general version of the equation that I'm about to fill in. And that's just a good habit to get into, is if you just, I know it feels tedious when you're first starting, but when you're looking back over your work, or if I'm looking over your work, it just makes it a lot easier to read. So I always try to do my empty equation first. So y minus y1 is m times x minus x1. Okay. So here, if I kind of map this out, this is my x1, this is my y1, and my slope is -1. Oops, that didn't turn out. There. So I can kind of distribute these things. So now I'm going to fill in, so y minus 4 is -1 times x minus -2. Okay. Remembering that x and y are just going to be allowed to vary, right? So they're variables, so we don't need to fill anything in there. And now I'm going to rearrange and solve for y, just because that's typically how we display lines. So I've got y minus 4 is -1 times x plus 2. So I'm going to distribute this and say, okay, well, that's negative x. Well, I guess I should take it a little bit slower. It is our first day back after reading break. So maybe I'll go a little bit slower here. So x plus 2, there we go. And then I'll distribute that -1, right? This -1 has to multiply on top of the x and the 2. So y minus 4 is -x minus 2. So now I need to solve for y, which means I have to add 4 to both sides. So I get y is -x minus 2 plus 4. So y is -x plus 2. -2 plus 4 is plus 2. Notice that here, right, x, whatever's attached to the x is the slope. It's just negative. Technically, it's -1, but we don't write the 1 multiplier, right? So we just have -1, which makes sense, right? Because we were told that the slope is -1. So it should be attached to the x. He was just finding that y-intercept, right, is a little bit more work because we don't actually have it. We have a different point. We have -2, 4. Okay. So what happens? I encourage you to go through and make sure that you can do all of these, right? But the idea stays the same. You can just plug in the values that you know and then solve for y. There you go. But the one that I want to go through is 29, where we have to do that extra step first of finding the slope. But because I have 2 points, I can find the slope. So here we go. 29. Through 2, 1, and 1, 6. Okay. I'll make a note here. If we have 2 points, on the line, we can find the slope. Right? So that's where we started. So it is going to be kind of a hand-in-hand section here where we have to kind of, oh, okay, I know how to find the slope. So the slope is y2 minus y1 over x2 minus x1. Right? And we already did a problem like this, right? So here the slope is going to be, I'm going to use this as my subscript 1s and the second point as my subscript 2s, just because that makes sense in my mind. As long as you're consistent, it doesn't matter. So I've got 6 minus 1 over 1 minus 2. Okay. So I've got 6 minus 1, that's 5. Over 1 minus 2 puts me at negative 1. What I'm going to do is I'm going to rewrite this as negative 5, because 5 over 1 is just 5, right? And then this negative, what's confusing about negatives is this negative can float out front, it can float to the top. As long as you only have one negative, you can kind of float it around wherever it looks good. So this becomes negative 5. And you can try it on your calculator. 5 over negative 1 is just going to give you negative 5. So now we have a slope of negative 5. What does that tell me? Well, it tells me a lot about this line, right? It tells me that I'm going to have this negative slope, right? But also 5 is quite steep, so it's going to be kind of like this. It doesn't really, I don't know if it reflects very well when I do it with my hands, so we're going to have quite a steep slope here. Not that it matters, but it's okay. All right, so now I have the slope, and I don't just have 1 point, I have 2 points. It doesn't matter which point I choose to use. They're going to give me the same line, right? So I'm going to use 2, 1, okay, and that'll be my point for my point slope form. So we only need 1 point for the point slope form of the line. So I'm going to let x1, y1 be the point. Let's do 2, 1. Maybe later what you can do is you can just play around with it and see what happens if you use 1, 6. Shouldn't matter. So I get y minus y1 is m times x minus, x minus x1. Okay. So I've got y minus 1 is negative 5 times x minus 2. So I'm going to rearrange this and solve for y. So I'll keep y minus 1 over here on the left-hand side for a little bit, and then I have negative 5x plus 10. Right, negative 5 times -2 is +10. And then if I add 1 to both sides, I get y equals -5x plus 10 plus 1. So y is -5x plus 11. Now what I want to do is, why don't we have a look at this in Desmos and see what it looks like, and just make sure that it's running through both of these points that we were given. Right? So let's see here. Desmos, been a while. So I'm going to do y equals -5x plus 11. Notice it has those properties that we were expecting it to have, right? Quite steep and negative. And so here, okay, my y-intercept is at 0, 11. We don't really talk about the x-intercept too much, but it's where it crosses the x-axis. Now, the points that we were given, let me just refer back here, were 2, 1. So when x is 2, let me see if I can get there. 2, 1. Okay, so that point is on the line. That's good, because that's what we wanted. Okay. How about 1, 6? So 1, 6 should also be on the line here. So I'm going to go till x is 1, 1, 6. Oh, there. Try to hold it steady. Okay. Both those points that we wanted to be on the line are on the line. I'll show you a little trick for instead of having to trace along there, because I know Desmos can be a little bit finicky when you're tracing along the lines. So what if I just did, okay, when x is equal to 2, x is equal to 2, it means it's always equal to 2 regardless of what the y value is. That's going to give me a straight up and down line, a vertical line, right? So then that's at 2, 1. And what if I wanted to see when x is equal to 1, right? Those were my two x values. Okay. So 1, 6, that's good. And when x is 2, I'm at 2, 1 at that intersection, right? And so that's one way that you could do it. Or if you wanted to look at the y values instead, right? So in 2, 1, y equals 1. Well, that point is still at 2, 1. And at 1, 6, y is equal to 6. Y equals 6. So you can just pick either the x values or the y values and just draw straight lines, and then you can find the intersection using Desmos, just to confirm that those points that you wanted on the line are actually on the line. Okay. So either way, it doesn't matter, but kind of useful, right, to check your work. Okay. So okay, I want to give you guys a little bit of a break. We'll do a break until 9:15. How about just a little break? I know, but enough time to grab some coffee. Break until 9:15. Okay, so not really relevant anymore. So if we go back to those notes that I've got for you, right, so here, one thing is that, so any linear equation just has some multiple times, oh, it's lagging a bit here. So something times x plus something times y plus something for c equals 0. Notice that there's just an x and a y. The highest powers of x and y are 1. And so we know we're going to have some sort of equation of a line, right? And so as long as you're able to recognize a line, then that's good, right? So for all of these, right, y and x, okay, so I've been able to rearrange and I've got it in the form of y equals mx plus b here. Same thing for the next one. Here, I can see right away that I could rearrange this into the form of y equals mx plus b, right? And then same thing for the following 3, right? As long as you're able to recognize that all of these I could rearrange into the form of y equals mx plus b. And so then you could find the slope and the y-intercept, and then they're saying to draw the line. I don't want you to do that because that just, we can use Desmos instead, but I do have the note here, right? So to graph a line, a straight line, any straight line, you just need to have 2 points. It helps if you have more than 2 points, but you only need 2 points on the line. And then you connect them with a straight edge and then extend the line, right? And so one way that you can do that, so I kind of want to go off the grid here, okay? So I'll just bring in this little note here because it is going to be really important. Okay, so to graph a line, right, we need to find 2 points on the line and connect them and then extend the line. Now, instead of doing exactly what we're told here, okay, in these examples, what I want to do is I want to show you how you can find any 2 points on the line and then graph them, right? And so all of these equations can be rearranged into y equals mx plus b, rearranged into y equals mx plus b, right? So they're all straight lines. I want to have a look at, this one just feels too, well, I want that negative. So maybe we will do 62. It just is really similar to that example that I just kind of made up earlier, but I mean, I guess we're not that creative. 62, so 3x minus 4y equals 12. So what I want to do here is, first thing, I feel more comfortable working with lines if they are in the form of y equals mx plus b. So then what I'm going to do is I'm going to rearrange this by solving for y. So I get negative 4y is 12 minus 3x. Okay. And then solving for y, right, I have to divide by negative 4. And so I get y is 12 minus 3x, all divided by negative 4. Now, if I distribute this, right, both 12 and minus 3x are over 4. So I get y is 12 over negative 4 minus 3 over negative 4 times x. Okay. So what happens, right, 12 over 4 is 3, and so divided by negative 4, though, becomes negative 3, so y is negative 3, and you can do it on your calculator, and then plus 3 over 4x. So what the question is telling us to do is, okay, find the slope and the y-intercept and then draw its graph using that information. I'm going to take it one step further and just say, okay, we're going to draw this graph. Now, what I want to do is I want to pick values of X. And so I've got this little, I can put in a little, I can do those stickers. That's not really what I meant. Stickies, a grid. How about that? Okay. So if I make my XY plane like this, and it's only because I'm really bad at drawing the positive sign. So here, this is -3 over -4, right? So technically this is -3 over -4. And so a negative over a negative makes a positive. Does that make sense? Awesome, good. Yeah, so you wanna keep track of those, right? You wanna keep all your negatives, but also make sure you make them positive if they have to be. So what I'm gonna do is, right, remember we only need 2 points on the line in order to draw this line. Okay, so we need 2 points on the line. We need 2 points on the line. So what I usually do is I set up a little table, and what I'm going to do is I'm going to plug in values of X. So I'm going to say, okay, what if X is 1? Well, then I have -3 plus 3 over 4 times 1 is my Y value, right? So I can plug in any value of X and figure out what my Y value is. Now, the key is you want to pick convenient values of X, right? Because X has to be divided by 4. So you want to pick kind of nice values. My go-to is, of course, letting X be 0. Letting X be 0 puts me on the Y-axis, right? Which is also the Y-intercept. So what I do is I make a little table like this, a table of values. So I've got, if X is something, then the Y value, then Y equals -3 plus 3 over 4 times X. Okay. So you just pick convenient values of X. Okay. And so I'm going to let X be 0, which means that Y is -3 plus 3 over 4 times 0, which is just going to be -3. So this point, this first point that I have is at 0, -3. And I'll have to move this over a little bit here because I want to have, so my XY is at 0, -3. There. Okay. Then I want to pick something, an X, right? And with practice, you'll kind of start to see what are some easy values of X. Now, X being 4 would be easy, right? Because then you have 4 divided by 4. And so now, let's do X is 4. Then Y is -3 plus 3 over 4 times 4. And if you use your calculator, right, you'll find that that's 0, right? And I know that because 4 divided by 4 becomes 1, and then 1 times 3 is 3. -3 plus 3 is just 0. So I don't have enough room to show all that work. So just kind of convince yourself that that's true. And then the point that I'm looking at is at 4, 0, right? When X is 4, Y is 0. When X is 0, Y is -3. So you pick convenient values of X. I'll put convenient. Convenient meaning values that are easy to plug in and solve for y. So you can pick x equals 1.1, that's fine. It's just hard to find where 1.1 is on the grid, right? So another thing you'll want to keep track of is the x's that you put in here should probably be in the given grid that you have, right? So we want to keep track of all those things. So pick convenient values of x, then solve for y, for the corresponding y value. Okay. Okay, so now I want to plot these points, 0, -3. Okay, so let's use green for this one. So when x is 0, y is -3. Uh-oh. I'm going to have to move this grid line a little bit here. Like that, maybe. Because I needed to have -3 here. So if I've got -1, -2, -3, 1, 2, 3, 4, 5, maybe, and then 1, 2, 3. So my first point is at 0, -3, and so when x is 0, I'm at -3. This is at 0, -3. Oh, shouldn't use that. My next point is at 4, 0. So when x is 4, y is 0. And those just happen to be on the x and the y-axis. And just as a little note, right here in the origin, I'm at 0, 0. That's not a point on the line. I'm just kind of emphasizing that that's the origin, 0, 0. So I know these 2 points are on the line here. And so how about we take a straight edge, right? And so, I don't know, just kind of looking around. I've got my mouse pad here, so I can use that to connect these dots. And let's see if it'll let me this time. Right? I line it up. No, it doesn't like it. It's having a bad day today, I think. Good thing I can sort of cheat. It didn't really go through the dot down here. It's okay, whatever. Right, so you connect the 2 dots, you take your straight edge and you make sure that they're connected, and then you extend the line because the line keeps going and going and going. Okay, so that's how you draw any straight line, but also how we find these XY ordered pairs, right? So these are the ordered pairs out here. Okay, so all right, good. Anything else I wanted to say here? I feel like there was something, but I lost it. It's okay. We'll survive. All right. So lines, right? If we have, oh, that's what I wanted to do. I wanted to graph it in Desmos just to confirm, because we have these easy points to check, right? We may as well use them to make sure in Desmos that we're getting the same thing. That's what I wanted to do. Now, to really make sure that I did this all right here, what I'm going to do is I'm going to graph this original function, or this original equation, I should call it, in Desmos, right? So I'm going to plug in 3x minus 4y equals 12. What it will do internally is just basically solve for y and then draw the line, right? So if I give it this, it should just draw the line. And then we can confirm, right, that these 2 points are actually on the line. So it was 3x minus 4y equals 12. So 3x minus 4y equals 12. Okay. So here, let's just confirm, hey, it looks good, and it looks like the line that we just drew. So that's good, right? Good, good, good. Okay, so that's great. And also, if you think about plugging in 4, 0, right? So this point here, 4, 0, when x is 4 into 3x minus 4y and y is 0, you get 3 times 4 is 12, so 12 equals 12. That's true, right? So for all these x, y coordinates, 3x minus 4y is going to equal 12, regardless of what the combination is. Okay, good. So the last kind of concept I want to talk about today is perpendicular or parallel lines. So 2 lines are parallel if they have the same slope. Okay. So I'll grab them from here. So 2 non-vertical, right? Because we can't have vertical lines like this because those have no slope, right? And so that we can't work with those. But 2 non-vertical lines are parallel if and only if they have the same slope. Okay, so even if they're overlapping like this, we would say that they're parallel. So if we have kind of 2 lines like this, usually we would say M1 and M2, right? The slope of line 1 versus the slope of line 2, right? If they're parallel, if 2 lines are parallel, we know, right, they have the same slope, which means that M1 must be equal to M2, right? So here, mathematically, this is how we would show that 2 lines are parallel, okay? So the slope of the first line is equal to the slope of the second line. Okay. How about if they're perpendicular? Perpendicular is a little bit harder, right? Because now perpendicular is when you have something like this, right? You've got a 90-degree angle between the 2 lines. So for perpendicular lines, have a little bit of a trickier property, but as long as we keep track of this property, it's going to be easy to identify perpendicular lines. So perpendicular lines might look something like this. So my default line like this and like this. Kind of. And I'll use that little, oh, doesn't look very good, little box here to indicate that that's a 90-degree. Oh yeah, you bet. There. So I use a little box in the corner to indicate that it's a 90-degree angle. Awesome. Even though it doesn't really look like 90 degrees, but they're at a perfect, they're perpendicular to each other. So there are a couple of things or ways that we can identify perpendicular lines. Again, we're going to have maybe M1 here and M2 here. Doesn't matter which one is which, right? But line 1 and line 2. call friendly on line 1. So, right, if you have two slopes, M1 and M2, they're going to be perpendicular if and only if M1 times M2 is equal to -1, right? So see here that, okay, we need to have the two slopes. And then if we have the two slopes, if they're equal to each other, we can say they're parallel. And if they're not that, then I can check to see if they're perpendicular by doing the slope of the first line times the slope of the second line. If that equals -1, then they're perpendicular. So if two lines are perpendicular, we know that M1 times M2 must be equal to -1. Another way that we could check this is that, okay, well, M2, if we wanted to solve for M2, it doesn't matter which one, but if we wanted to solve for one of these slopes, right, I'd have to divide by the other one. And so if I'm solving for M2, for example, it would have to be -1 over M1. Right? Or solve for M2, then you get M2 is -1 over M1. Now what you'll find is it depends on the information that you have for which version of these you want to use. It doesn't really matter, right? Because this one you can easily morph into M2 is -1 over M1. I just find that this first one, then multiplying to -1 is the easier one to remember. So I just remember that one. And then if I need to solve for one of the slopes, then it's easy to do. So there is a little footnote here, not really a footnote, but a little kind of side note. So a horizontal line, remember a slope of 0, we're going to say it is perpendicular to a line, so a vertical line with no slope, which you would probably say just looking at them. But it's hard to do because mathematically, right, there's kind of a complicated proof here that we're not going to go into because a vertical line has no slope. So how would you prove that? But anyways, we'll leave that for a higher math course. So we're just going to take it as fact. Okay, so a horizontal line is perpendicular to a vertical line. Feels obvious, but we'll accept it. We'll take it. Okay. So let's do some examples here. And then I also want to kind of expand your mind a little bit with another example. So after this, and so let's start with 75. Okay. So we've got the equations of two lines are given. Okay, determine whether the lines are parallel, perpendicular, or neither. Okay. So we're going to have to rearrange these and find the slopes of each one, and then we're going to use those slopes to determine if they're parallel or perpendicular, or maybe neither, right? Often these lines are neither parallel or perpendicular. So 75, I've got -3x plus 4y equals 4. And then on the other side here, I'm going to do them kind of side by side just to save space, I guess. 4x plus 3y equals 5. So solving for y in both of these situations, because if I have it in the form of y equals mx plus b, then it's easy to find the slope. I can just pick out the coefficient of x. So I have 4y equals 4 plus 3x. and 3y equals 5 minus 4x, kind of doing them simultaneously here. Fancy, right? Got page break here, so y equals 4 plus 3x over 4, but also on the other end here, y equals 5 minus 4x over 3. For these problems, I'm only concerned with the slope, right? And so that's the coefficient of x. And so here I've got y equals 4 over 4, which you could write as 1 if you wanted, plus 3 over 4 times x. Here I've got y equals 5 over 3 minus 4 over 3 times x. So what I've got here is, let's say m1 is 3 over 4. Now, it doesn't matter which one is which, right? m1 or m2. I'm just labeling as they come here. So then m2 is going to be negative 4 over 3. Once I'm here, it's obvious to me that these are not the same, right? And so what we can say, we can start and we can kind of go through our list. Since m1 does not equal m2, right? 3 over 4 is not the same as negative 4 over 3. We know these lines are not parallel. We know these lines are not parallel. Okay. So what I'm going to do then, because I have m1 and m2, what I'm going to do to see if they're perpendicular is I'm going to multiply them together. Oh, a little bit slow there, sorry. I'm going to multiply them together and see if I end up at negative 1. If I do, then they're perpendicular, right? So now what I'm going to do is try m1 times m2. m1 is 3 over 4 times m2, which is negative 4 over 3. Got some nice cancellation going on here. It looks really promising. 3 over 3 makes 1, and then 4 over 4 makes 1. So I'm just left with negative 1. So m1 times m2 equals negative 1, which by that property says that these two lines are perpendicular. Therefore, these lines are perpendicular. Right? What if we did 74? Let's go back here. I'm gonna just grab it here. Copy. Paste. So here, this one is already in the form of y equals mx plus b. So here I can see the slope. Here I'm going to have to solve for y equals mx plus b, but that's okay. So I've got y equals 1 over 2x plus 4, and then 2x plus 4y equals 1. So now, solving for y in the second line, because I need to have it in the form of y equals mx plus b, I get 4y is 1 minus 2x. So then y is 1 minus 2x over 2. Nope, 4. Nice try. So then I have y equals 1 over 4 minus 2 over 4x. You can reduce that to negative 1/2 if you want. I'm just going to keep it as negative 2 over 4 just to kind of show you that it'll still work. So now I'm going to let m1 be 1/2. And here, m2 is -2/4 or -1/2. It doesn't matter which one you use. This one's negative, this one's positive, so I can already tell that m1 is not equal to m2, right? You want to be careful because even though it's -1/2, that's not the same as 1/2 +1/2, right? This line is not the same as this line. They have the same slope value, right? But one's going in the positive direction, one's going negative, right? So m1 does not equal m2, therefore they're not parallel. Okay, so then I'm going to check to see if m1 times m2, so I'm going to multiply these together, and if I end up at -1 like I did earlier, then they're going to be perpendicular. So 1/2 times, I'll just do -1/2 for simplicity's sake. Multiplying two fractions, I just multiply across, right? So I get -1/4, which is not equal to not -1, right? Therefore, not perpendicular. So these lines are neither parallel nor perpendicular. So the last example is one that I've got here on the side. So you'll want to write this one down because it's not in those notes. And I'm just kind of pushing you a little bit to work with these lines and really solidify everything that we've talked about today. And so what I want to do is I'll write down the example, and then I want you to work on it, and we'll start class next day and we'll work through it, right? So this is probably one of those times where you have to remind me, hey, we were going to go through a question, but anyways, so I'll state the question here and then I'll let you go. Find the slope of a line perpendicular to 2y minus 4x minus 5 equals 0. Okay, so we have to use a lot of things that we've covered today, but I'll let you think on that one, work on that one a little bit and see where you get to. And that's where we'll pick up next day. All right. If you have any questions, let me know. Otherwise, I'll see you on Thursday. Crazy. Week's flying by already.